So let us see in this slide. So port numbers are actually the integer values between 0 to 65,535, and some range of these port numbers are actually reserved. Port numbers helps the operating system of receiving machine to identify the process to deliver the packet to. A process running on the machine, if register a port number, say 60,001, for example, all packets which have 60,001 as destination port number in their TCP or UDP header will be delivered to this process by the transport layer. So you can see that port number is actually identifies the application which is interested in receiving the packet. And those packets which have destination port number as 60,001 will be delivered to the application which is actually listening on port number 60,001. The application has to tell the operating system that, hey, I am interested in receiving all the TCP or UDP packets which are coming with destination port number blah blah blah. So let us take an example here that you have a source machine S and we have a source machine D, destination machine D. On the source machine S, we are running three applications, app 1, app 2 and app 3. App 1 is listening on port number 50,001, app 2 is listening on port number 50,002 and app 3 is listening on port number 50,003. Similarly, app 4, app 5 and app 6 are listening on port number 60,001, 60,002 and 60,003 respectively. Now suppose app 1 wants to send a data to app 5. Right? Now for the app 1 to send a data to app 5, what should be present in the TCP header? That is, what should be the source port number and destination port number specified by the app 1 in the TCP header. So in the TCP header or UDP header, the app 1 has to specify the source port number as 50,001 and the destination port number as 60,002. Right? So this will complete the transport layer header. In the IP header, the application 1 has to specify the IP address of machine S, which could be the IP address of any local interface, but again it's a good practice to specify the IP address of a loopback interface of machine S. And the app 1 also has to specify the IP address of the destination machine. So this completes the IP header. So if the app 1 wants to communicate with the app 5, the app 1 has to specify the port numbers as well as the IP address. Then only the end-to-end communication between the source application, that is app 1, and the destination application, that is the app 5, is possible. So while the IP layer uses this information to take the packet from source machine S to destination machine D, once the packet arrives on the destination machine D, the transport layer on the destination machine D uses the information that is encoded in the transport header to deliver the packet to the correct application which is interested in this packet. Now when this packet is received on destination machine D, the transport layer will check the destination port number in the packet, and it finds that the destination port number in the packet is 60,002. So it will check that what are those applications which are listening on port number 60,002. So the operating system will find that the application 5 is the machine which is listening on port number 60,002. So the packet will be delivered to application 5. Remember, there could be more than one applications which are registered or which are listening to the same port number. If that is the case, the transport layer will going to hand over the packet to all those relevant applications which are interested in receiving that particular packet based on port number they are listening. So like source and destination IP address and IP header, source port number and destination port number in the TCP UDP header never changes. Only source and destination MAC address in the Ethernet header changes hop by hop. Now, so if process, that is app 2, running on machine S wants to send data to any process, that is app 5 running on machine D, that is application 2 running on source machine S wants to send data to application 5 running on destination machine D. Application 2 needs to specify the following information. That is application 5's host machine IP address. Host machine means the machine on which application 5 is running. So the app 2 needs to know D's IP address. App 2 also needs to know the port number on which application 5 is listening. So in this case 60,002. Right? So these two pieces of information, that is the IP address of the destination machine and the port number of the application which is interested in receiving the packet. These two information the source application app 2 needs to know. Rest of the information required to deliver the packet is gathered by the operating system of sending machine, that is operating system of machine S, or intermediate machine such as TCP sequence number or source and destination MAC addresses, etc. So as an end user or as a programmer, you need not to find the source and destination MAC addresses, because source and destination MAC addresses keeps on changing hop by hop. So the operating system does it by itself using ARP table and ARP broadcast request and all that stuff. As an end user, you need to specify the destination machine's IP address and the port number of the application running on destination machine. If you know these two information, then you can set up end-to-end communication between the two applications.